everyone, we are going to start talking about how to write the equation of a polynomial today. We're going to talk about the equations of polynomials when we know what the graph looks like. So before we start, I just want to talk about generally what graphs of polynomials look like. And so I have three images of different polynomials, and I just want to show some properties of all three that they all three have in common. The first is that the graphs of the polynomials are all smooth curves. So they're kind of like roller coasters. They go up and down and back up. But the key is that they don't have any sharp edges, all smooth curves. Next, something we're not going to talk very much about, but they all have in common is the end behavior, which is the arrows at both ends. And if you look at the end behavior, all of them have arrows at both ends. And those arrows are either going upwards, which means they're going towards infinity, or they're going downwards, which means they're going towards negative infinity. And lastly, the property that's most important to what we're going to talk about are what the zeros look like on the graph. And zeros, we just interchangeably call them three different things. Zeros, sometimes we call them x-intercepts, sometimes we call them roots. So you should be familiar with all three of those words. They all mean the same thing. And that is where the graph touches the x-axis. So I'm just going to point out the zeros on each of the graph. Remember, so the x-axis is the horizontal axis. So the zeros are here. This graph has 1, 2 zeros. The next graph, here's my x-axis. The next graph has 1, 2, 3. And the last graph, here's my x-axis, has 1, 2, 3. And we'll get into more about what those zeros tell us in a minute. So what we're going to talk about next is a specific form of an equation of a polynomial. And this is the form we're going to work most often with, and it's called factored form. We've also talked about factored form when we studied quadratics. Looks very similar. So this particular example of factored form, the general form, you can see I'm going to highlight the factors. There's a factor, there's a factor, there's a factor. And what the factors have in common is that they all start with an x. So there is an x in each factor. That helps me see how many factors I have. Each factor has a z, so x minus z. There's one, there's one, there's one. And there's just a subscript, z1, z2, z3, meaning these are different z's. And the z stands for a 0. So this is 0 number 1, 0 number 2, and 0 number 3. And the ... means that there could be more than 3 zeros, right? So there could be 4, 5, 6. It could go on to infinity, technically. The other thing I want to point out is that between the x and the 0, in our general form, we use a minus sign. And that minus sign is really to help us remember that when we put a 0 into a factor, we always do the opposite symbol. So if our 0 is positive, we use a negative symbol. If our 0 is negative, we use a positive symbol. And the last thing about factored form is this letter A out front. That's the A value. And the A value actually tells us a little bit about the end behavior. It tells us about the behavior of the graph in general. We're not going to talk too much about it, but we are going to determine what the A value is of certain graphs today. So that A value is very important. So now we're just going to do an example, multiple choice, where we look at a graph and we try to match the graph to its correct equation using what we just learned. So I just want to talk about the options we have over here. Notice that they are all in factored form, right? I can see the factors separated by parentheses. I also notice that the A value is the same in every single one. Do you notice how the A value is the same? So that means we're not really concerned about the A value. We're really trying to figure out which factors describe the graph. So let's look at our graph. For our graph, to find the factors, we need to first find the zeros. So I'm going to highlight my zeros. I have a 0 right here, and right here. And there's not numbers there. I'm going to zoom in a little bit. This one is at a positive 1, this is -2, and this is -3. Okay, so I'm going to jot something down here, and once you get good at this, you might not have to write it down every time, but my zeros are -3, -2, and +1. Now, we talked about how a 0, we use the opposite symbol in the factor. So if my 0 is -3, that means that the factor is x plus 3. If I have a 0 at -2, the factor is x plus 2. If I have a 0 at +1, the factor is x minus 1. So I'm looking at an example here of my options A, B, and C, and D that has x plus 3, x plus 2, and x minus 1. And I see that here, option C. I do want to talk briefly about option D. Option D is very close. Do you see how similar they are to each other? But the difference is that option D has an extra x. And in our next example, we'll talk about how that actually makes that option D incorrect. So for this one, you might want to pause the video, this example 2, and try this one on your own. It's up to you. Or you can just listen to another example if you need it. So I'm going to do the same thing I did last time. I'm going to look at my zeros. I have one here, that's -3. I have one here, that's at 0. And I have one here, that's at +1. Okay, so I'm going to jot down what I did last time. My zeros are -3, 0, and 1. So -3 produces a factor of x plus 3. 0 produces a factor of x, and I usually do the opposite symbol. 0 doesn't have a symbol, so it actually doesn't matter. I could do +0 or -0. And what's important here is that x minus 0, or if you wrote x plus 0, that is the same as just x by itself. X minus 0 is just x. All right, and this last one, +1, that means the factor is x minus 1. So I am looking, my solution should have a factor of x plus 3, a factor of just x by itself, and a factor of x minus 1. All right, so let's look at our answers. We're looking for an x plus 3, an x minus 1, and an x by itself. And I see that answer here, letter D. X plus 3, x minus 1, x by itself. Notice how the a value here is actually just a negative symbol. That's what they all have in common. And that means that the a value for all of these is -1. We don't write the 1, but it is actually -1. All right, so this next part is probably the most important example for today. And this is really what the goal for today is. It's to write our own equation of a polynomial given a graph. And I have 4 steps we're going to follow. Before we do that, I'm going to write a reminder of factored form. Remember, factored form looks like this. F of x equals a value, and then I have factors that we write like this, x minus z1, x minus z2, and our factors continue. All right, so I'm going to read these steps and we're going to do them one by one. Step 1 says use the zeros of the graph to write an equation in factored form, leave the a value, which means we're going to leave this a value here in our factored form. All right, so let's do that first. So I'm going to just start it off, f of x equals, and I'm going to write a because I know I'm going to leave the a value. And now I have to write out the factors. So I look at my graph, and I can see that on my graph, I have 1, 0 right here at 2, and 1, 0 right here at 8. So when I write those as factors, remember I do the opposite. So I'm going to do parentheses, x minus 2, opposite of +2, parentheses, x minus 8. That is step 1. I'm going to cross this off, check it off. Step 2, identify another point. that means I can't use the two zeros I just found. I can't use this point or this point. Identify another point and plug this point into your equation for x and y. So let's look back at our graph. There will always be a point that's clearly marked. And I can see that point right here. I know this is small. Clearly marked, I'm going to write the coordinates, 0, 12. 0 is an x value, 12 is a y value. So step 2 says to take that point and plug this point into your equation for x and y. So one thing that you do have to remember to do this is that f of x is a fancy way of just writing y, right? So when I say plug in for x and y, I mean replace y here and replace x here and here. All right, so I'm going to replace the y with this coordinate right here, 12. 12 equals a. And I'm going to replace the x with the x coordinate, 0. 0 minus 2, parentheses, 0 minus 8. All right, so I did step 2. I plugged in a point for x and y. Step 3 says solve your equation for a, and that's going to determine the a value. So I'm just going to solve this equation. To do it, I'm going to do this order of operations. So I'm going to do what's in parentheses. 12 equals a. 0 minus 2 is negative 2. 0 minus 8 is negative 8. Now I'm going to multiply these two numbers. So I'm going to get 12 equals negative 2 times negative 8 is positive 16. And I'm going to write it with the 16 first, 16a. And we just have to solve that equation for a. So to solve for a, I divide both sides by 16. And I get a equals 12 over 16. Let's reduce that. A equals 12 over 16. If I divide the top and the bottom by 4, I get 3/4. So my a value is 3/4. If you're more comfortable writing 3/4 as a decimal, you can. You could write it as 0.75 if you wanted to do that. Delta Math would accept a decimal as well for these practice examples. All right, and then don't forget about your final answer. This is the most important part. Your final answer is the equation, our original equation that we wrote, but now I know what the a value is. So I'm going to rewrite my final answer as the equation f of x equals, my a value is 3/4, x minus 2, x minus 8. That is my final answer. That is the equation that matches this graph. All right, we have one more example we're going to try. We're going to do those 4 steps. I don't have the steps written down this time. We're going to just go through them. So the first thing that we have to do every time is we have to identify the zeros and write our general form. So let's look for our zeros. Here's one. This one is at -3. I have one right here at 0, and I have one right here at +3. So I have to take those 3 zeros and put them into a general equation. So I'm going to say f of x equals a. It always starts with an a value. And for this one, if you remember from our example we did earlier, 0 produces the factor x minus 0, which is really the same thing as just x by itself. So this general equation, one of the factors is just x by itself. And I like to put that first right after the a. So I have a times x, that's one factor. Parentheses, now I'm going to do, so we did this factor. Now I'm going to do this one. A -3 becomes x plus 3. And then this one is a +3, so that would be x minus 3. So I have 3 factors. All right, next I choose another point. And there's a point already chosen for me. If you see, it's clearly marked. 2, -20. 2 is my x, negative 20 is my y. I take those values and I plug them in. This is where I plug in y. This is where I plug in x. I have 3 places to plug in x. All right, so I'm going to plug in negative 20 equals a. I'm going to put parentheses around this x, so x is 2, and then 2 plus 3, and then 2 minus 3. All right, so let's keep working to solve our equation for a. Negative 20 stays the same. And then I have a, 2. 2 plus 3 is 5. 2 minus 3 is negative 1. All right, so I'm going to keep negative 20 here. Let's multiply these 3 numbers. 2 times 5 is 10, times negative 1 is negative 10. So I'm going to write negative 10a. And then to solve for a, I divide by negative 10. And I get a equals negative 20 divided by negative 10 is 2. I just get a whole number, 2, as my answer. Last step is to remember to write your final answer as an equation. So my final answer is this equation that I started with, but remember I know what a is now, so I replace a. So my final answer is f of x equals 2x, x plus 3, x minus 3. And that is the equation that matches this graph. All right, there's one more example that you guys can try on your own, so I'll leave that on the screen to end. You can practice that one on your own. All right, good luck.